Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video problems, sample problem videos in calculus, in particular about continuity. So this is important in determining points of discontinuities so that you can use that in your engineering subjects, not just in calculus. So for those who want to anticipate the solution, the principle is presented in the earlier part of the video on continuity so that you will have an idea how to find them. You can pause the video and anticipate the solution by your own. So these are the problem exercises. Find the points of discontinuity of the following functions: cosecant theta, secant theta, quantity 1 plus x to the 1 half, 1 plus x, quantity 1 plus x to the negative 1 half, quantity 1 minus x to the negative 1 half, square root of x square minus a square, square root of 1 plus square root of x, then square root of quantity a plus x over x square minus a square root of quantity x square minus 2ax plus a square, and square root of 2ax, quantity 2ax minus x square over a square minus x square, and three more here. So let's have cosecant theta first. We can rewrite this as 1 over sine theta. And sine theta is, we have a denominator. This will be undefined or discontinuous when sine of theta is 0. Sine of theta is 0 at values of theta in radians 0, pi, plus minus pi, sorry, plus minus 2 pi, plus minus 3 pi, plus minus 4 pi, and so on and so forth. So in general, the points of discontinuity would be those values of theta where sine of theta is 0. And these are 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, etc. In general, it is equal to n pi, points of discontinuity where n is any integer. So that's it for problem 1. For problem 2, secant theta can be written as 1 over cosine theta. And again, we have a denominator here which can be 0 at values of theta like plus minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on and so forth. So these are the points of discontinuity because cosine of these angles in radians will be 0, and this makes secant theta undefined. So therefore, in general, points of discontinuity would be n pi over 2, where n is any odd integer. Number 3, since there's no denominator for number 3, and within its domain, that is continuous within its domain. So therefore, there's no point of discontinuity for number 3, because even if it is negative 1, square root of 1 plus negative 1 is square root of 0, and square root of 0 is 0, so it is defined. Therefore, there's no point of discontinuity, so there's none. Number 4, we can write this as 1 over 1 plus x to the positive 1 half. And we have the denominator here, which can be 0 when x is negative 1, 1 plus negative 1. So 0, and square root of 0 or 0 to the 1 half is 0. So this is undefined when x is negative 1. Therefore, the point of discontinuity is negative 1. Number 5, we can write this as 1 over quantity 1 minus x to the positive 1 half. And again, this is the denominator, which can be 0 when x is positive 1. So the point of discontinuity is x is 1. Number 6, there's no denominator. So within its domain, this is defined everywhere within its domain. So therefore, there's no point of discontinuity. So none. Number 7 also, there's no denominator. And therefore, it is defined everywhere on its domain, which is 0, x should be greater equal to 0. So this is defined everywhere. Therefore, there's none also within its domain. Defined everywhere within its domain, which is x is greater equal to 0. This one has a denominator, which is x squared minus a squared, which can be factored into x minus a, x plus a. So therefore, the points of discontinuity would be those where the denominator is 0 plus minus a. You may factor this as x minus a and x plus a. So the roots are x is plus minus a. Number 7 has no denominator. We can rewrite this as x minus a quantity square, square root of quantity x minus a quantity square. So there's no point of discontinuity within its domain. Number 10, there is denominator again, and we factor this as a minus x, the denominator, over a plus x, as well as the numerator, but it doesn't matter the numerator as long as it is defined everywhere. So x is, that will make the denominator 0, is x is a and x is negative a. So if x is negative a, the numerator also will make it undefined. Negative a, quantity 2a minus negative a, so that's square root of negative. So therefore, the points of discontinuities are plus minus a. Then another 3 sets of problems. Find the points of discontinuity of the following functions. 11, x minus absolute value of x. 12, y equals signum of x. 13, y equals negative of quantity 1 plus signum of x, sine of x. Remember that when x is negative, less than 0, absolute value of x is negative x. So this reduces to x minus negative x, or 2x. And when x is 0, 2x is 0. And 2x is defined everywhere, even if it is negative or positive. When x is greater than 0, then absolute value of x is just x. So this results to x minus x, which is 0. That's fine. Then when x is 0, it is also equal to 0. Therefore, there's no point of discontinuity for number 11. So none. Number 12, y is signum of x. We know that when x is negative, signum of x is negative 1. When x is positive, signum of x is positive 1. And when x is 0, signum of 0 is 0. So those are different values. Therefore, the point of discontinuity is when x is exactly 0. Because when x is exactly 0, signum of 0 is 0. If it is just to the left of 0, signum of x, which is signum of a negative value, is negative 1. And signum of just to the right of 0 is positive 1. So they are different values. Then when x is 0, it is 0. Therefore, the point of discontinuity is x is 0. Then number 13, let's simplify that into negative 1 times sine x, so negative sine x minus signum of x, sine of x. Then when x is negative, x is less than 0, signum of x is negative 1. So if this is negative 1, we have negative sine x, negative of negative, so positive sine x. So y is 0 when x is 0. This reduces to y equals 0 when x is less than 0 or x is negative, because signum of negative value is negative 1. So that is negative sine x minus negative 1 of sine x. So that's negative sine x plus sine x, which is 0. So y is 0, and 0 is a defined value. And when x is 0, the whole expressions would also be 0. Then when x is greater than 0, signum of x is positive 1. So this becomes negative sine x minus sine x. So that means it is equal to negative 2 sine x. When x is negative, it is defined. Negative 2 sine x is defined. When x is positive, negative 2 sine of positive x is also defined. When x is 0, negative 2 sine of 0 is negative 2 times 0, 0. So therefore, for this function, there's no point of discontinuity, because when x is 0, the value of y is 0. So none for number 13. So that's it for this video. I hope that you learned something from this video.